The next one says a bag contains 25 red, 55 blue, and 60 white checkers. If a checker is selected at random, what is the probability that the checker is not blue? Okay, so if the checker is not blue, there's two ways we can approach this. We can talk about the probability of it being blue. All right, so there are 55 blue checkers, and there are a total of, let's see, of 140 checkers. And then I would just have to reduce that fraction. And when I reduce that fraction, the 55 over the 140 gives me an 11 over 28. That's for getting blue, so not blue would be everything else. And remember, these have to add up to 1. So not blue would be a 17 out of 28. Okay, that's the first way we can look at it, by looking at the blue and then say, okay, everything else has to be not blue. So we subtract the probabilities from 1. But then for the other approach, you could just look at it right from the start. If I don't want blue, I'm looking at the red or the white. Well, there's a total of 85 of those. So if I do 85 over the total of 140, again, I reduce that fraction. It's going to give me a 17 over the 28. Okay, so those are the two approaches. But again, either way, you should get the 17 over 28. Okay? Number 19, it says a box containing tiles labeled A through L. What are the odds of selecting a vowel? So we have a box that has the letters A through L in it, and we want to know the odds of selecting a vowel. So when we say A through L, that means it's got an A, B, C, D, E, F, G, H, I, K, and L. Okay, so this is the list of letters we have. We looked, that's a total of 12 letters. Remember, odds is favorable versus unfavorable. So we're talking about vowels here. I'm going to take the vowels, the A, the E, and the I are the vowels that we have listed. So there's 3 vowels. So it's 3. And then we use a colon, so it's 3, 2. Favorable versus unfavorable, the things that I don't want is everything else. So I count up the things that are left, and there's 9 total things that are left that I don't want. So the odds are 3 to 9. But then again, remember, we have to reduce that just like we do a fraction. So that's going to be odds of 1 to 3. Take a look at the next one. It says a comedy club orders a batch of 8,400 squeaky rubber chickens. If the probability of a defective squeaker is 2.7%, about how many would you expect to be defective? We're going to round this to the nearest whole number. And there's 2 ways of looking at this. We can either look at it in terms of the percent. We can just multiply the 8,400 by the percentage that we're using. And remember, we always want this percentage as a decimal. So as a decimal, this is going to be 0.027. And we just have to multiply the 0.027 times the 8,400. And that gives us a 226.8, but it asks us to round to the nearest whole number, so it's 227. The other option for doing this is if we set up a proportion. Remember, percentage, it's like 2.7 out of 100. And then we want to know how many out of the 8,400. And then we could use this and we could cross multiply the 2.7 times the 8,400. 22,680. And then again, divide each side by the 100. And when we do that, we get the same thing that we just got a moment ago. We get x equals the 226.8, which rounded to the nearest whole number is 227. So no matter which way you do it, either way you get the same answer. So either multiply the percentage by how many you have, by the total number to find that percentage, or set up a proportion. In the next one, it says a widget factory produces 750 widgets each day, and 11 are found to be defective. What is the probability that a widget selected at random is defective? Okay, so this time it asks us to write our answer as a percent. And remember, for a probability, we just put the number of defective things since we want the probability of defective. If there's 11 of those, out of a total of 750. Well, there's our probability as a fraction. We just want to write it as a percent. So if we divide these two numbers, it gives us the 0.0146 repeating. And then if we want to write that then as a percentage, we just move the decimal place over 2 spots. So it's a 1 point. And then the 4, I look at the number behind it, it's a 6, so it's going to round up to 1.5%. And that's to the nearest tenth. Okay? Next it says a hat contains 12 spheres and 8 cubes. If an object selected at random, if an object is selected at random and then replaced, so we're going to pull that object out, we're going to put it back in the hat, we want to know what's the probability of getting a sphere and then a cube. Okay, so the probability of a sphere and then a cube. So the probability of a sphere, there's 12 spheres out of 20 total objects. So we pull a sphere out, we put it back in. Now the probability of a cube, there's still 8 cubes. There's still 20 objects total because we replaced the first object. And since this is an AND probability, it means we're going to multiply. So when we multiply these, we can reduce this a little bit. The 12 over 20 reduces to a 3 over 5. The 8 over 20 reduces to a 2 over 5. And then we can check to see if this cross reduces, but it looks like it doesn't. I multiply straight across. That's going to give me a 6 over 25. So the probability is 6 over 25. And we can just leave it like a fraction. Okay? In number 23, we've got a couple different questions we're being asked about this scenario. It says a jar contains 12 blue, 8 red, and 4 white marbles. Marbles are drawn at random without replacement. So without replacement means we pull them out and we don't put them back. If we want the probability of blue then white, well, the probability of blue is 12 over the total, which is 24. And then a white, well, let's assume that I pulled the blue one out. So now there's less blue, there's less total, but there's still 4 white marbles. But now there's only 23 marbles total. This is a then probability, which means and means we multiply. And now we just have to reduce this thing a little bit. The 12 over 24 reduced to a 1 over 2. And then I can cross-reduce the 4 and the 2, reduced to a 1 and a 2. And I multiply straight across. Looks like it gives me a 2 over 23. In part B, we want the probability of red, then red. So if the probability of a red, there's 8 red out of 24 total. So now I assume that I pulled one of the reds out, and it's without replacement. So that means I only have 7 reds left in my jar. I only have a total of 23 marbles left in my jar. Okay, so again, it changed the probability. These are dependent events. Then again implies and, so it's an and probability. I reduce, the 8 over 24 reduces to a 1 over 3. It doesn't look like I can do anything else in the way of reducing, so I'm just going to multiply straight across. That's going to give me a 7 over a 69. Looking at part C essentially is the same thing. It's just another way we can word a problem like this, except we're looking at the white marbles this time. But if I want both to be white, well, it's 4 out of 24 for the first white marble. I assume that I pull one of those white marbles out. I don't put it back because it's without replacement. But this essentially means the same thing. It means white and then a white. So now there's only 3 white marbles left because I pulled one out. There's only 23 marbles left total in the jar because I pulled one out. So now I'm going to multiply these because it means a white and then a white. So it's still an and probability. The and is implied. And now I can reduce. The 4 over 24 reduces to a 1 over 6. I can cross-reduce the 6 and the 3, reduce to a 1 and a 2. And now I can multiply straight across. That's going to give me a 1 over a 46. And that's it. The last piece of this says odds against red. All right, so a red marble, there are 8 red marbles. So those are the things I want versus the unfavorable event. So it's favorable versus unfavorable. There's 16 other things that I don't want, so it's 8 to 16. That's odds for a red. For odds against, I have to flip this. So I have to flip these around. Odds against, I list the unfavorable first, which is the 16. versus the favorable, which is the 8. And now again, I have to reduce these just like I would a fraction. Each of these divisible by 8, so it reduces to 2 to 1. Okay, so the odds against red is 2 to 1. In number 24, it says the chart below shows the sum of two number cubes being rolled. Okay, so obviously if I roll a 1 and a 1 together, it's a sum of 2. If I roll a 4 and a 3, it's a sum of 7. So it gives me all the different possibilities when I roll two number cubes here. If two number cubes are rolled, what is the probability that the sum will be 4 or 7? All right, so if I look at the 4s, here's the 4s. Those are my possibilities for a 4. It looks like there's 3 of them. Okay, so there's 3 ways that I could roll a 4 out of a total. If I look at the total here, there's a total of 36 different things that can happen if I look at all the numbers that are listed. So it's 3 out of 36. For a 7, if I look at the 7s, here are the 7s. I want 4 or 7. It looks like there's 1, 2, 3, 4, 5, 6 ways that can happen. So it's a 6 out of 36 total options. And this is an or. Or means we add. So I'm going to add these together. So 3 over 36 plus 6 over 36 is a 9 over 36, which of course reduces to a 1/4. So the probability of a sum of 4 or 7 is 1/4. For number 25, it says a class of 15 girls and 10 boys. 5 of the boys and 7 of the girls are wearing black shirts. The rest are wearing orange shirts. And we want to know if one is selected at random, what's the probability that they are a girl or they're wearing an orange shirt? Okay, so unlike the last example is mutually exclusive because those two things can't occur at the same time. It can't be a sum of 4 and 7 at the same time. But these ones are inclusive because it can be a girl and they can be wearing an orange shirt at the same time. Okay, so we're going to treat these a little bit differently because we're going to have to subtract the overlap. But for a girl, if we're looking at the girls, there are 15 girls out of a class of 25. In terms of folks that are wearing orange shirts, it told me that 5 boys were wearing black shirts and 7 girls were wearing black shirts, and everyone else was wearing an orange shirt. So there's 12 that are wearing black shirts, so that means there's 13 that are wearing orange shirts out of the 25 students. This is an or probability, which means I'm going to add. So I've got the girls, I've got the orange shirts, but the problem with this one is that it's inclusive or overlapping, so we have to subtract the overlap. In other words, we have to subtract the girls that are wearing an orange shirt. Okay, so if we looked, there were 7 girls that were wearing a black shirt. There's 15 girls total, which means that there are 8 girls that are wearing an orange shirt. And the reason, again, that we have to subtract these things is because those 8 girls were counted amongst the folks that were girls, and then they were counted again during the second probability of those wearing orange shirts. So we've counted those 8 girls twice, so we have to subtract the overlap. Okay, so I'm going to add these together, and then I'm going to do the subtraction. And we can see what happens when we add those first 2 fractions. We get a 28 over 25, which doesn't seem to make any sense because we've added those 8 girls twice. Now when we subtract that overlap, it gives us a 20 out of 25, which reduces to a 4 over 5. Okay, so again, when these things are overlapping, when they're inclusive, we have to subtract the overlap. Okay? Last one here, number 26, it says a teacher places the names of 50 students in a hat. The teacher pulls names at random without replacing them to create groups of 7 students. You are one of the 50 students and are not selected in the first group. What is the probability that you are the first student selected for the second group? And really, this problem isn't nearly as complicated as it seems. The goal here is just to use our imaginations and put ourselves in the shoes of what's happening here. We started with 50 students in this hat. The first round has already passed, so 7 students have already been selected from this 50. We started with 50 students. 7 have already been selected, so now we're down to 43 students in the hat. And we're about to start the second trial of this thing. We want to know if you're the first student selected out of the hat for the second group. Well, there's only 43 names left. You're the only one who has your name on that slip, so there's one of you out of 43 students left in the hat. So this is just a 1 out of 43. And again, it's just getting us to think, to put ourselves in the shoes of this situation and be able to decide what the probability is. Okay? Hope this was helpful and good luck on your test tomorrow.